The double-slit experiment. This is the experiment that broke reality. In 1801, scientists fired electrons through two slits. When no one was watching, the electrons acted like waves, creating an interference pattern, multiple paths at once. But the moment they placed a detector to observe which slit the electron went through, everything changed. The wave collapsed. The electrons acted like particles, taking only one path. The act of observation changed the outcome. This is the double-slit experiment, and it proves that reality does not exist in a fixed state until it is measured. Particles exist in superposition, every possible location at once. Until you look, then they choose. In a simulation, this is render on demand. The system does not waste processing power rendering things no one is looking at. It keeps objects in a probability cloud and only loads the final texture when a player observes it. You are not discovering reality. You are creating it by looking. Quantum entanglement. Einstein called it spooky action at a distance, and it terrified him. Quantum entanglement is when two particles become connected. No matter how far apart they are, if you measure one, the other instantly changes, not at the speed of light. Instantly across any distance, even across the universe. Scientists have proven this in labs. Entangled photons, separated by miles, react to each other instantaneously, faster than light, which should be impossible. Einstein hated this because it violates the speed limit of the universe. Information is not supposed to travel faster than light, but entangled particles do not care. They are connected outside of spacetime. In a simulation, this is client-server synchronization. Two objects share the same memory address. When you update one variable, the other updates instantly. Not because a signal traveled between them, but because they reference the same data. They are not two separate things. They are two pointers to the same object. Distance is irrelevant. The Planck length? There is a smallest possible measurement in the universe. Smaller than atoms. Smaller than quarks. Smaller than anything. It is called the Planck length. Below this scale, the concept of distance breaks down. Space and time stop making sense. You cannot zoom in any further. Why? Because the Planck length is the resolution limit of reality. Just like a computer screen is made of pixels, the universe is made of Planck units. If you try to measure something smaller, quantum foam takes over. Space-time itself becomes unstable, fluctuating, uncertain. You hit the render limit. In a simulation, this is the base resolution, the smallest unit the physics engine can process. Below the Planck length, there is no more data, just noise. The system cannot compute geometry at that scale, so it stops. Reality is not infinite. It is quantized. It has pixels. And you just found the smallest one. The Fermi Paradox. There are 200 billion trillion stars in the observable universe. Billions of planets. Billions of years of time. Statistically, intelligent life should be everywhere, but we have never found any. Not a signal, not a trace, nothing. This is the Fermi Paradox. If aliens exist, where are they? Some say they are too far away. Others say they destroyed themselves before reaching us. But here is the darkest answer. The Great Filter, a trap in evolution that wipes out civilizations before they become spacefaring. Maybe we already passed it. The dinosaurs didn't. Or maybe the filter is still ahead of us. AI, nuclear war, climate collapse, and every species that reaches our level hits the same wall. In a simulation, this is the single-player hypothesis. You are the only conscious observer in this instance. The universe is not multiplayer. It is procedurally generated for you alone. NPCs exist to populate the world, but no other players are logged in. You are playing solo, and the silence is the proof. The speed of light limit. Why is the speed of light exactly 299,792,458 meters per second? Why not faster? Why not slower? And why can nothing in the universe exceed it? Einstein discovered that the speed of light is the universal speed limit, not because light is special, but because it is the speed at which information can propagate through spacetime. If you try to go faster, time itself slows down to stop you. Your mass approaches infinity. You would need infinite energy. The universe says no, but why? Why does reality have a speed limit? In a simulation, this is the frame rate cap. The speed of light is how fast the simulation processes updates. 299,792,458 meters per second is the tick rate of the physics engine. Information cannot travel faster than the server can compute. If you try to exceed it, the system throttles you. Time dilation is lag compensation. Mass increase is processing load. You are hitting the hardware limit. The universe has a maximum refresh rate, and light speed is it. Subscribe to Fudge here for part 2. We are just getting started. The holographic principle. You think you live in 3 dimensions: length, width, and height. But cutting-edge physics suggests you might be wrong. The holographic principle states that all the information in our 3D universe is encoded on a 2D surface, like a hologram. Everything you see, everything you experience, is a projection from a flat boundary. Think of it like this. A hologram on a credit card looks 3D, but all the information is stored on a 2D surface. Our universe might work the same way. Black hole physics proves that information is stored on the surface, not the volume. String theorists believe our reality is projected from a distant 2D plane. You are not a 3D being. You are a 2D pattern that thinks it is 3D. In a simulation, this is texture mapping. Complex 3D worlds are built from flat image files. Your depth is an illusion. You are pixels on a screen, rendered to look volumetric, but fundamentally flat. Quantum tunneling. In the quantum world, walls are not solid. There is a chance, however small, that a particle can pass straight through a barrier without breaking it, without using energy. It just appears on the other side. This is quantum tunneling, and it happens constantly at the atomic scale. Electrons tunnel through barriers in your computer chips. Nuclear fusion in the sun happens because protons tunnel through electromagnetic repulsion. Even you, theoretically, could tunnel through a wall. The probability is just absurdly low, but not zero. Every particle has a wave function, and that wave extends beyond physical boundaries. So there is always a tiny chance it exists on the other side. In a simulation, this is collision clipping. When objects move too fast or have glitched hitboxes, they pass through walls. The physics engine fails to register the collision, and the object teleports to the other side. Quantum tunneling is reality's version of no-clip mode. The universe allows it, because solid matter is just a probability distribution, and sometimes the dice roll in your favor. Last Thursdayism. Scientists say the universe is 13.8 billion years old. But here is the problem. We cannot prove anything existed before last Thursday. This is called last Thursdayism, a philosophical argument that the universe could have been created 5 minutes ago, with all your memories pre-installed, with fossils already in the ground, with light from distant stars already in transit. You cannot prove it is not true. Every piece of evidence could have been manufactured at the moment of creation: the cosmic microwave background, the expansion of space, radioactive decay. All could be part of the initial conditions. In a simulation, this is loading from a save file. When you start a game, the world does not render from the Big Bang. It loads a snapshot of a pre-built state. The history is just lore written in the code. The universe could be 5 minutes old, and you would never know, because your brain was created with false memories. Reality does not need a past. It just needs to look like it has one. Vacuum energy. Empty space is not empty. Even in a perfect vacuum, with no matter and no light, space itself is filled with energy. Scientists call it vacuum energy, or zero-point energy. Quantum mechanics predicts that empty space should be boiling with virtual particles, popping in and out of existence, borrowing energy from nothing, and paying it back before the universe notices. This energy is real. It has been measured. It is what causes the Casimir effect. 2 metal plates in a vacuum will attract each other, because the space between them has less vacuum energy than the space outside. But here's the problem. When physicists calculate how much vacuum energy there should be, they get an absurdly large number, 10 to the 120 times larger than what we observe. This is the cosmological constant problem. Why is empty space almost empty, but not quite? In a simulation, this is idle RAM usage. Even when nothing is loaded, the system uses a baseline amount of processing power. Background tasks, system monitoring, memory overhead. The universe is never truly off. It is always running something. The fine-tuning problem. The universe has about 30 fundamental constants: the speed of light, the gravitational constant, the mass of an electron, and they are all perfectly tuned. Change any of them by 0.00001%, and the universe collapses. Stars would not form. Atoms would not hold together. Chemistry would fail. Life would be impossible. This is the fine-tuning problem. Why are the settings so precise? There are 3 explanations. Luck, we won a cosmic lottery with odds of 1 in 10 to the 120 multiverse. Infinite universes exist, and we just happen to be in one that works, or design. Someone set the parameters. In a simulation, this is the config file. The developer carefully chose the variables. Gravity at 6.67 times 10 to the negative 11. Speed of light at 299,792,458. If any value was slightly different, the simulation would crash. The universe is not random. It is calibrated, and someone wrote the settings. Subscribe to Fudge here for part 3. The evidence keeps getting darker. Time dilation. Time is not constant. It moves at different speeds depending on how fast you are moving. This is time dilation. Einstein proved it. If you travel close to the speed of light, time slows down for you, but not for everyone else. Astronauts on the ISS age slightly slower than people on Earth because they are moving at 17,000 miles per hour. GPS satellites have to account for time dilation, or they would give you the wrong location. Time is not a universal clock. It is a local experience. Your present is not the same as someone else's present. If you traveled at 99% the speed of light for 1 year, you would return to Earth decades in the future. You aged 1 year, everyone else aged 50. In a simulation, this is frame rate desync. Different objects in the game process time at different rates. Your character is running at 60 FPS, but something moving faster is running at 10 FPS. From their perspective, time is slower. From yours, they are fast-forwarding. Time is not a dimension. It is a processing rate. Dark matter. Galaxies spin too fast. According to the laws of physics, they should fly apart, but they do not. Something invisible is holding them together. We call it dark matter, and it makes up 85% of all matter in the universe. But we cannot see it. We cannot touch it. We can only detect it by the gravitational pull it creates. Scientists have been searching for dark matter particles for decades, building massive detectors underground, but they have found nothing. No particles, no interactions, no proof, just the effects. Galaxies move as if there is mass we cannot see. In a simulation, this is hidden collision mesh. Objects you cannot render, but that still have physics. Invisible walls in video games. Barriers that block movement but are not visible. Dark matter is the universe's hitbox. You cannot see it, but it is there, affecting everything. The question is, why is it hidden? The delayed choice experiment. The delayed choice experiment is one of the strangest in physics. It is a version of the double slit experiment, but with a twist. Scientists fire a photon through 2 slits, but they do not decide whether to measure it until after it has already passed through. The photon has already traveled. The past has already happened. But the moment they choose to measure which slit it went through, the photon's history changes. It retroactively becomes a particle instead of a wave. The past is rewritten by a future observation. This suggests that the past does not exist in a fixed state. It only solidifies when you look back at it. Before observation, history is in superposition. All possible pasts exist at once. Until you measure, in a simulation, this is retroactive rendering. The system does not store every frame. It only generates the past when you query it. If you never look back, the history does not need to exist. The universe saves memory by not rendering the past until you check. And when you do, it creates a timeline that matches your observation. The past is not recorded. It is generated on demand. The measurement problem. In quantum mechanics, particles do not have definite properties until you measure them. An electron does not have a location. It exists in a cloud of probabilities, everywhere at once, until you observe it. Then the wave function collapses, and it becomes real. This is the measurement problem. Why does observation force reality to choose? What counts as an observation? Does it require a conscious mind, or just any interaction? No one knows, but the math is clear. Before measurement, particles exist in superposition. After measurement, they have definite values. The act of looking creates reality. In a simulation, this is lazy loading. The system does not calculate exact values until they are needed. If no one is checking, the variable stays undefined, a placeholder. When you query it, the system runs the calculation and locks in a result. Reality is not predetermined. It is computed on the fly, based on who is looking. Quantum immortality. Here is a thought experiment. You are standing in front of a quantum gun. It fires. In one universe, the gun works. You die. In another universe, the gun jams. You survive. According to the many worlds interpretation, both universes exist. But here's the catch. You only experience the timeline where you survive. Because in the other timeline, there is no you to experience anything. So from your perspective, the gun always jams, every time, forever. This is quantum immortality. Your consciousness can never experience death. It always continues in the branch where you survive. No matter how unlikely, to everyone else, you died. But to you, you just keep getting lucky. The car swerves, the bullet misses, the diagnosis is wrong. You are unkillable, not because you are special, but because dead timelines have no observers. In a simulation, this is the main character clause. The player cannot see the game over screen from first person. Your consciousness is always rooted to the save file where you are still alive. Death is just a branch you never experience. You are immortal by default. Subscribe to Fudge here for part 4. The final evidence will break your brain. The Pauli exclusion principle. Matter feels solid, but atoms are 99.9999% empty space. So why can you not walk through walls? The answer is the Pauli exclusion principle. It states that no two electrons can occupy the same quantum state. When your hand gets close to a wall, the electrons in your atoms repel the electrons in the wall, not because of physical contact, but because the universe forbids identical particles from overlapping. It is a rule written into reality. Without it, all matter would collapse into a single point. Your body would phase through the floor, atoms would merge, chemistry would not exist. The Pauli exclusion principle is what makes matter solid. It is not physical force, it is a law of identity. In a simulation, this is collision detection. Objects cannot occupy the same coordinates. The engine checks positions every frame. If two hitboxes overlap, it applies repulsion force. You are not feeling the wall. You are feeling the system rejecting duplicate position data. Solidity is just an error message. Object already exists at this location. Entropy. The universe has a direction, toward disorder, toward decay. This is called entropy. The second law of thermodynamics states that entropy always increases. Hot things cool down, organized systems fall apart. Energy spreads out and becomes useless. You cannot reverse this. You cannot unbreak an egg. You cannot unmix a cup of coffee. The arrow of time points toward maximum entropy. Stars will burn out. Black holes will evaporate. Eventually, the universe will reach heat death, a state of maximum entropy where no energy differences exist. No motion, no light, no life, just uniform, cold emptiness. Forever, this is the inevitable end. In a simulation, this is memory decay. The longer the system runs, the more corrupted data accumulates. Errors compound. Systems degrade. Eventually, the simulation reaches a state where no meaningful computation can occur. The universe is not eternal. It has an expiration date, and entropy is the countdown timer, the uncertainty principle. There is a fundamental limit to what you can know. The Heisenberg uncertainty principle states that you cannot measure both the position and momentum of a particle at the same time. The more precisely you know where something is, the less you know about where it is going, and vice versa. This is not a limitation of our instruments. It is a law of nature. The universe does not allow you to have complete information. Why? Because at the quantum level, observation changes reality. Measuring position disturbs momentum. Measuring momentum disturbs position. The act of looking affects the thing you are looking at. Information is inherently incomplete. In a simulation, this is data protection. The system does not store both values simultaneously. It calculates them on demand. If you query position, momentum becomes undefined. If you query momentum, position becomes undefined. The universe saves processing power by not tracking redundant data. You are not allowed to see the full state, because the full state does not exist until you choose what to measure. Reality has a privacy setting, and you cannot bypass it. The big crunch. The universe is expanding. Galaxies are moving away from each other. But what if it stops? What if gravity wins? The Big Crunch theory suggests that if there is enough mass in the universe, expansion will eventually slow, then reverse. Galaxies will start moving toward each other. Space will contract faster and faster until everything collapses back into a single point. A reverse Big Bang. All matter, all energy, all space, crushed into an infinitely dense singularity. And then, maybe it bounces. A new Big Bang, a new universe, an endless cycle. Expansion and contraction. Birth and death. Forever. In a simulation, this is a server reset. When the game world becomes too corrupted or resource-heavy, the admin shuts it down, wipes the map, and restarts from scratch. The Big Crunch is not an ending, it is a reboot, and you will not remember the previous version. Antimatter. For every particle in the universe, there is an opposite. An electron has a positron. A proton has an antiproton. Matter has antimatter, and when they touch, they annihilate. Both particles are destroyed, converted entirely into energy. This is the most powerful reaction in physics, more powerful than nuclear bombs. But here is the mystery. The Big Bang should have created equal amounts of matter and antimatter. But our universe is made almost entirely of matter. Where did all the antimatter go? Why are you made of matter and not antimatter? No one knows. Somewhere there should be an antimatter version of you, made of the same atoms, but reversed. If you ever meet, you both explode. In a simulation, this is the inverted asset. Every object has a mirrored version in the code, positive and negative. But only one loads into the game world. The other is kept in reserve, or deleted. You are the matter version. Your antimatter twin was despawned at launch. But the fact that it existed means the code supports both. Subscribe to Fudge here if you are still in the simulation, because after watching all 4 parts, you cannot unsee the evidence.